Greetings, we're going to do 149-150. Now 149 I don't like because it doesn't say what I want it to say, but let's start reading it. A planning board in Elm County is interested in estimating the proportion of residents that are in favor of offering an incentive to high-tech industries. A random sample of Elm County was selected. All the residents were asked, are you in favor of the incentive? So that's definitely, they're asked, are you in favor, yes or no? A 95% confidence interval. So it appears as if 54% of the people in the sample said it, and they created a 95% confidence interval, and they want to know, what does that mean? Or what would be correct now that you know that? Well, a lot of these I like. What it really means when we create a confidence interval is that 95% of the time we would capture the true proportion, and that true proportion would fall somewhere within that interval. But we can't say this. 95% of the time the true proportion would fall within this interval. So all we really know is it would fall within that interval 95% of the time, because we're searching out the truth and we cast a really big net to try to figure out where the truth would fall. So if I add that, I get 0.59, and if I subtract that, I get 0.49. So maybe this one says a little bit more what we're looking for. It says, in repeated sample, the true proportion of the residents in favor will fall in the interval. We love it, but will fall within the interval 95% of the time. And they left that out. Very mean. So I've already eliminated D and E, even though those are the words that I really like when I do a confidence interval, because that's what it means when I create a confidence interval. So let's keep reading. It says, in repeated samples, 95% of the samples will fall in the interval. Well, it's kind of like what I'm doing, but what I'm doing is casting a net, trying to seek the truth, and I know that the truth lies somewhere in my net. And that's not really what this is saying. At a 95, a majority, no, that's not what that's saying. So this one has to be my best choice, and so I'm going to have to stick with A. At a 95% confidence level, the estimate of 0.54 is within 0.05 of the true proportion of county residents in favor of the offerings. Next question. This one states a group of students have 60 houseflies, so it's definitely a design question. We're going to take these houseflies and we need to assign them each 20 to each of three groups. So you start with 60, you need to split them up. 20 to group A, 20 to group B, 20 to group C, and you got to be very specific about this. So let's see what would be the best way to do it. It says each of the three groups were labeled A, B, C. They're capturing the flies one at a time as they enter a chamber that's baited with food. Which of the following method would be most likely to result in three comparable groups? So when I look at the first, it says label the first 20 flies caught as A. Well, the first 20 flies caught, if you're baiting them with food, are just the hungriest. So that's really, really bad. We don't want to design a study where everybody gets stuck in group A that happen to be the hungriest, because there may be an association between hungry and whatever it is I'm trying to study. So looking at B, it says write letter A, B, and C on a separate slip of paper. Sounds good so far. Randomly pick one slip of paper and assign the first 20 flies caught to that group. So now I am being random, but I'm actually ensuring that either group A, B, or C has the hungriest or the most aggressive. So we know that the flies that run to the bait the quickest are going to fall into one of the groups, and you're nice, you are being random with which group you assign the hungriest, but one of the groups is going to be lumped with all the hungriest, and we don't want that. So let's keep reading. When each fly is caught, we roll a dice, okay? If the dice shows an even number, fly is A. If a dice shows odd, fly is B. When 20 flies have been labeled A and 20 have been labeled B, All the rest are C. So here's what's happening. C stands for crappy. These are the lazy flies. So we're ending up assigning each group randomly, but whatever dice roll. So let's say you roll a dice 1 through 6 and you just so happen to like never roll a 5, which we know that would happen. So there's going to be one number we just happen to not roll. Whatever number I assign to that is just going to be all the crappy lazy flies are going to be shoved into that one group. So this is not a great assignment. Let's look at D. It's longer, so maybe if we took more time to assign, it would be better. So it appears as if we place each fly in its own number container, 1 through 60, I'm liking it already, and we order them. Write the number on the jar, 1 through 60, put the slip in a jar, mix them well, pick the 20 numbers out, assign the fly to each container. Each fly here had an equal chance of being chosen, regardless of their sleepiness or laziness or hungriness. Each of these 60 had an equal chance of getting into group A, and then B, and then C. So I'm liking it. There's probably something wrong with E. Let's figure it out. When each fly is caught, roll a dice. If the dice shows 1 and 2, a fly is A. If the dice shows 3 and 4, label B. 5 or 6, label C. Repeat it for all 60 flies. Once again, you're going to stack the deck for one group and then shove everyone else in the end, which are not caught. So once again, one group is going to have the laziest flies or the least hungry flies. And that's probably not a good way to design an experiment. We're going to go with D. Thanks for joining us.